Welcome to Study Loop.
Hello friends, here in the problem it is given, you should follow the diagram from the book. Assembly shown consists of pieces of sheet of aluminum of uniform thickness and total weight 7.2 pound and welded to the axle supported by the bearings A and B. Assembly is initially at rest when a couple M0 is applied on the axle AB, knowing that angular acceleration is 150 radian per second square. I cap calculate couple apply on the axle and B dynamic reaction at A and B. Dynamic reactions. Mass of each sheet metal. Total mass is given. So you may find mass of sheet metal aluminium. It is given 2.7 upon 32.2, that is 0.08385 pound square upon feet, or you may write 0.08385 slugs. Now sheet metal having the dimension B is equal to 6 inch, that is 0.5 feet. So area of the assembly you can find, area will be half V square. See the figure, V square. There are two rectangular and two triangular, right angle triangular. So it will be 3V square, 3 into 0.5 square. So you will get 0.75 feet square. So you can find the density. So density of the sheet you will get mass upon area. Mass per unit area you are finding. Mass is 0.08385 divided by 0.75 slugs slugs per feet square, and its value will be 0.1118 slugs per feet square. This is mass per unit area. Remember it. This is not mass per unit volume. It is mass per unit area. Remember it. Now moments and product of inertia, we will find moments and product of inertia. I mass can be written as rho into area. Let us see here. Moment of inertia of this portion separately. I am drawing here geometrically. Let us see here. Just a moment. Let me of this portion. This is B. This is A. As you can say, this is B. This is B. This is B. This is your x-axis. This is your y-axis. So Ix. This is B. This is B. You can write each dimension is given B. So Ix you may write 1 by 3 b to the power 4 plus 1 by 3. So it becomes 2 by 3 of b की power 4. So Ix to be rho into 1 by 2 by 3 b की power 4. Substitute the value. Rho already we have calculated density mass per unit area, and V is 0.5 to the power 4. So on solving it, this would be 4.658 10 to the power of minus 3 slug feet square. Similarly, you can find Ixy. It can be written as b square into 3 by 2b square b into half of b plus b square 5 by 2b minus half b, then you will get minus half b to the power 4. So it will be this is area. Now in terms of mass, minus 1 by 4 rho b की power 4. So you will get, sorry, this is 1 by 4. Let me correct it first. Substitute the value. Density is 0.1118.5 to the power 4. So on solving it, this value will be minus 3.4938 slugs feet square. Now this portion we have to find. I am drawing here roughly. This is the point A. Then this will be this one. Triangular portion. This is B point, x-axis, y-axis. All the terms are same. So you can write Ix to be now you are calculating xz plane. Ix will be 1 by 12 b square 1 by 12 b, that is 1 by 6 b की power 4. So Ix can be written as 1 by 6 rho b की power 4. Substitute the value. Rho is 1118, b is 0.5 whole to the power 4. So this would be 1.1646 10 to the power 3 slugs into feet square. For calculation, Ixz, you can directly, I am writing here, not doing the calculation here, I am writing. So Ixz, you will get minus 5 by 12 b to the power 4. So in terms of mass, its value will be minus 5 by 12 rho b की power 4 minus 5 by 12 rho is 1118.5 की power 4. So it would be minus 2.9115 10 to the power minus 3. I am writing in terms of slugs feet square, and Ix will be equal to 4.658 10 to the power minus 3 plus 1.1646 10 to the power minus 3. So it would be 5.823 10 to the power of minus 3 kg meter square. Now the mass center lies on the rotation axis, so acceleration will be 0. Since mass center lies on the rotation axis, therefore A will be 0. So you will get summation of F to be A plus B is equal to mass into acceleration, but acceleration is 0. So you will get A is equal to minus B. Now angular momentum about A will be Ix omega I cap minus Ixy omega j cap minus Ixz omega k cap. Here say this is equation 1. The frame angular velocity of frame of reference omega to be equal to omega I cap. So moment of couple about A to be rate of change of angular momentum of A, which could be written as plus omega cross HA. This is MO I cap plus 4B I cap cross dynamic reaction at B is equal to Ix alpha I cap minus Ix by alpha J cap minus Ixz alpha K cap plus omega I cap cross Ix omega I cap minus Ix by omega J cap minus Ixz omega K cap. Now simplify right hand side. We can write m naught I. First we will simplify this term. You will get minus 4b bz I cap plus 4b by k cap to be equal to Ix alpha I cap minus Ix by alpha minus Ixz omega square J cap minus Ixz alpha plus Ix by omega square K cap. Now equating the components of I cap, J cap, K cap. Unit vectors. First, for I cap, you may write MO to be Ix alpha, J cap, Bz is equal to Ix by alpha minus Ixz omega square upon 4b and K cap By is equal to minus Ixz alpha plus Ix by omega square upon 4b. Say equation 3, 4, 5. Substituting the value in these equations to calculate one by one all the parameters here given. Alpha is 150 radian per second square, omega to be 0, b is equal to 0.5 feet, Ixz, Ixy already we have calculated Ix. So answer of A part MO. Substitute the value Ix into alpha Ix. Already we have calculated 5.823 10 to the power of minus 3 into 150. So this would be 0.87345 pound into feet. So in vector expression you may write MO vector to be 0.87345 pound feet I cap. So this is the one of the answer we have obtained. Now B. Dynamic reactions at A and B. Bz You may calculate direct substitution are there minus 3.4938 10 to the power minus 3 into 150 divided by 4 times of V, that is 0.5. So you will get it is to be minus 0.262 pound. Similarly, you can find Vy minus 2.9115 into 150 minus 0 upon 4 into zero point 0.5. So this will be 0.218 pound. As you know, A vector, A reaction A is negative of B. So if we write reaction, dynamic reaction at V to B minus 0.218 J cap plus 0.262 K cap pound. So dynamic reaction at A will be 0.218 G cap minus 0.262 K cap. So this is the answer of B part of this problem. Thanks for watching it.